Hello everybody. Today we're going to be looking more at our exploration of quadratic functions, and specifically we're going to be looking at finding X-intercepts. It presents an interesting challenge because quadratic functions can be written in a variety of ways, and finding their X-intercepts can be easy or difficult depending on the format that we're given. Most students in Algebra 2, if we're asked to solve the equation, quadratic equation like this, where we let y equals 0 to find the X-intercepts, if we're trying to solve this equation in standard form, the first mistake that people make is they try to use inverses to get everything over to one side. But they run into a problem very quickly. So suppose we add 11 to both sides. Then what do? How do we get x all by itself? Some students will suggest divide by 6, but if you're going to divide by 6 correctly, you have to divide the entire right-hand side by -6 in this case. But that doesn't make things better. It actually makes things a little more complicated. So maybe we can divide both sides by x. If you do that, you're even more complicated than that. Now we have a variable in the denominator. So basically, trying to use inverses to solve quadratic functions in standard form is not easy to do. However, this is vertex form, and I learned that if we let y equals 0 there, to find the value of the x-intercepts in this case, or values of the x-intercepts, I'm just going to add 20. That's inverse of subtract 20. I'm going to square root, which is the inverse of square. I'm going to make positive and negative, which is the inverse of absolute value. And regroup and find two solutions, which are not nice numbers, but they are in fact consistent with my graph and everything else. But the point here is, if we have functions in standard or vertex form, I can find the x-intercepts. But if I have functions in standard form, I don't think I can. Yet. Now I look at this equation and I'm a little curious because what I see looks like a linear function times a linear function, and I'm wondering, well, is this a quadratic function? How could you tell? Well, I know one thing. If I was to distribute this, I would get x squared minus 5x plus 2 minus 2x plus 10. That's FOIL. First, outside, inside, last. And in so doing, I end up with this, which is clearly a quadratic function. So I go back to where I was before and say, look, if this is a quadratic function and I want to find the x-intercepts, 0 equals what would be the two possible solutions to this. I can't see the solutions when I see y equals x squared minus 7x plus 10, but I can see the solutions when I see this. If you haven't figured it out yet, notice the x minus 2 times something equals 0. What if x was 2? You would end up with 2 minus 2, which is 0, and 2 minus 5, which is -3, and 0 times -3 is in fact 0, which means x equals 2 is one of the solutions. Notice you could look at this equation and written in factored form, I would see that x is 2 is an obvious solution to this equation, and the other solution is should be obvious, that would be x equals 5. And just to show you how this works, I FOILed this all out and got an alternative form for the quadratic, but they're still the same function. So I should be able to put 2 in for x up here, and it should give me the, the value 0 when it's all said and done, because I've just found an x-intercept. And sure enough, 4 minus 14 plus 10, 4 plus 10 is 14, take away 14, we get 0. So we've definitely found the solutions to this equation. The other one is 5, because then we'll get 3 times 0, which is true. 0 equals 0, so x equals 5 is another one of my solutions. So what have I learned so far? Well, I've learned that vertex form is something that I can use to find x-intercepts for a quadratic function, but standard form, maybe not so much, unless my standard form equation can be written in factored form. If I can take this standard form and turn it into factored form, I could virtually read the solutions right off the page. And so that's the point. Excuse me. I'm going to look at these two functions side by side, and I would like to make the observation that the only way that I could possibly fathom solving this standard form equation when I let y equals 0 for the x-intercepts, the only way I can solve it is by finding vertex form. And the only way I know how to do that right now, there's other ways, but the way I know right now is I'm going to take the vertex, that is to say the axis of symmetry first, and get the axis of symmetry at 7/2, and then I'm going to put 7/2 into the function to get the y part of the vertex, which will be -2 1/4, or yeah, negative 2 1/4. So when x is 7 halves, y is negative 2 1/4. That's the vertex. So we can go y equals 1 times the quantity x plus 7 halves squared, that's the h squared, minus 9/4, which is 2 1/4. Now that I have it in vertex form, I can set that equal to 0 and apply inverses to both sides. This is all from last chapter, so it shouldn't be too difficult. Skipped a few steps down here to show us that x equals 5 and x equals 2. Now hold on a second. I look over this equation right here. I think I just talked about this. This is x equals 5. It makes this 0 times 3. And if this was x equals 2, then it would be 0 times negative 3 over here. Either way, same solutions. So look, if I had to choose between solving this equation by finding vertex form and then using inverses, or by taking this expression and factoring it, I'm going to choose factoring, because in factored form we can literally read the solutions right off the page. So now what we see is there's an incentive. There's a reason why we need to be able to take an expression in quadratic form, standard form, and turn it into factored form so that it makes it possible for us to solve the equation that we normally couldn't, and it also makes it less painful than doing all of this work right here. All right, that's going to conclude part 1 of this video because it's getting a little long, so I will pick up part 2 shortly.